So now that we are going to start talking about the geometric mean, we are going to start seeing some similarity properties applied to our right triangles. And in doing so, I'm going to try and connect that to the geometric mean. But here, looking at the geometric mean of a set of numbers is the nth root, where n is the number of elements in a set of numbers of the product of the numbers. Okay, the geometric mean of two positive numbers is x, such that you have a over x is equal to x over b, and x is my geometric mean. So think about when you cross multiply this. Let me zoom in, there's no reason not to. When I do cross multiplication, I end up getting x squared is equal to ab. And then, of course, we know in order to get x squared by itself, or x by itself, you would take and find the square root of both sides. So therefore, x is simply equal to the square root of ab. And I just, that's just doing that cross product property and coming up with that. When they ask for the geometric mean, the type of problem, the geometric mean between two numbers should be set up as this. Something over x is equal to x over something. I place my geometric mean values right here. What are those two values I'm looking for? It doesn't matter. You can actually set it up this way too. X over that number is equal to something over x. This will give you the same result as long as my two values that represent the geometric mean are, opposite of each other. Not opposite of each other, but, over that. Not sure what you would call that. But when we they would be in the cross product property location. So here, basically it says that Theorem 9.1 says, if an altitude is drawn to the hypotenuse of a right triangle. So here's my altitude, the height of a triangle. Here is my the right triangle, the highest point. Then the two triangles formed are similar to the original triangle. And they're just saying then, if that's the case, then I know that the h is going to be my geometric mean. The height of that triangle is going to be the geometric mean between the two pieces that it has intersected. And what I did here is I drew this, I just sort of redrew the pictures. So I have two right triangles, and they said they're similar. So what I did here is I took this portion of the triangle and said, hey, there it is, right? It looks something like that. So I have these two similar right triangles. And remember, when we're talking about similarity, we keep apples with apples and oranges with oranges. So I would have, this side over my height would be equal to this side over the base over the height would be equal to the base over the height, and that's how they end up with x over h is equal to h over y. And that's just using similarity to come up with this thing right here. And of course I did poor drawing, but that's the same thing. X over h is equal to h over y, because I'm using the cross product property to find similarity between two triangles. And then these rules, this is another rule, and they say that the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of the leg of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to the leg. So we have, we have the altitude, we have the hypotenuse AB, and I think they're saying, hey, that C over B, so my hypotenuse over the short leg, is equal to B, the hypotenuse of the little triangle over the short leg. Okay, so they're just showing you that we have these two similar triangles, the same thing that we just did in the previous one. And they do it right here where they say, hey, when I take and I do this altitude, what they've done is they've created three similar triangles by this altitude, and I've gone ahead and labeled them and showed you how do they, how are they similar? So just looking at that and being able to identify that. And that similarity is what is driving these theorems that we can prove. So again, it says the geometric mean here, the geometric mean between two numbers. There it is. These are my two numbers. Here's my geometric mean. I simply fill that in. You know, I would have between two numbers 5 and 45. When you do the cross product property, you get x squared is equal to x squared is equal to 225. You find the square root of both sides, and then we know that x is going to be equal to 15. Okay, 15 times 15 is 225. So there you go. So the geometric mean turns out to be that x is going to be equal to the square root of 225. So x is equal to 15. There you go. That's my geometric mean. So doing this check, feel free to do it on your own. Stop the video and keep, and then check it. But what they're asking us here is find the geometric mean between two numbers. Again, this is my geometric mean between two positive numbers. There you go. So when I cross multiply, you get x squared is equal to 12 times 15. So the square root of x squared is going to be equal to the square root of 12 times 15, which is going to be 30 times 6. So that should be 180, I think, if I do the math real quick. So x is equal to the square root of 180, which is approximately, it says put in simplest radical form. So let's see here. That should be, I think that is the square root of 36 times 5. So we know that the square root of 36 times the square root of 5, so that should be 6 square root of 5. So there you go. 6 square roots of 5. And that would be the simplest radical form. And hopefully you remember doing that. We should have done that yesterday. Okay, so now being able to orient yourself and identify these right triangles. This check, I would again make sure that you can split these up. We know that you're going to have 3 triangles, 3 right triangles. I'm going to have a little one. I guess I should give myself a little bit more room. I'm going to have a bigger one and going to have a bigger one. The bigger one is already labeled for us. And then the little one, this little fella right here, right? P represents the right triangle. The short leg represents K. The long leg is M. And then I have this other triangle right here. And then P represents my 90-degree angle. And then, of course, my short leg is K. And then, no, I'm doing the wrong one. P represents my 90, my short leg is M, and my other angle would be L. So those are your 3 similar triangles. And a similarity statement could be triangle KPN is similar to triangle MPL, which is similar to triangle KML. There you go. So being able to do the similarity statements. Which angles match up with which angles. So let's see here, moving forward. Again, using the geometric mean with right triangles, they told us that this over this should be equal to this over this. Doesn't do us a lot of good in this instance because we can't solve for x and y at the same time. But what can we do? Let's see here. They said AC, let's see here, find the values of x, y, and z, because we know that here AB is, x is the geometric mean of AD. So let's see here, Z, I got Z, which is going to be the geometric mean between AD and DC. So I'll skip down here and do that one real quick because that one seems to be the easiest. Z, this would be Z is the geometric mean of AC is equal to AD geometric mean Z, so I have Z squared is equal to 8 times 25, so Z, square root of Z squared is equal to the square root of 200, which is equal to, Z is equal to 10 square root of 2. Okay, so I know that this is 10 square roots of 2. Now, in this case then, if you look at this triangle, I have, in order to solve for y, you know, y represents the hypotenuse. This would be DBC, and I know that DB is 10 square roots of 2, and DC is 25. So if that's the case, I should be able to use the Pythagorean theorem to find out what that is, which, you know, we go, no, it's not written very nice, is it? This would be, we'll call this A, B, C, and I have A squared plus B squared is equal to C squared. And I started solving for y, but what we'll do is we'll hold off on that for a second, right here. And let's just go ahead and look at, again, I could have solved for x first. Again, doing the same thing where this is C value, this is my A, this is my B. And so then they get, you know, A squared plus B squared is equal to C squared. So you get something along the lines of 8 squared plus 10 square root of 2 squared equals C squared. This becomes C squared is equal to 64 plus 200. C squared is equal to 264. C is equal to the square root of 264, which they turn around and tell us this. So I didn't need to know that special rule here, that special ratio, if I was just able to use the Pythagorean theorem right there to calculate x. Nothing special, nothing new I had to learn. And then, so now once we have those, you can turn around and do the same thing, that if this is approximately 16, they said 16.2 or 2 square root of 66, again, you can use this length, and then this length to find this missing value. So you have, what they've done is they've, again, using the Pythagorean theorem, I caught a mistake here, which is funny. 25 squared is 625, which makes this 825. So then we can find out that the square root of 825 is C is equal to the square root of 825, which C then is approximately equal to, in this case, there's the answer, right? 5 square root of 33, or 28.7. So there's different ways to have solved for that problem, but tackling the first one, you know, using the height to find the geometric mean between these two is the easiest step, is to go ahead and solve for Z right off the bat. And then you can come back and solve for X and Y without knowing any special rules other than the Pythagorean theorem. So here, again, they've done it a little bit differently. Remember, this would be equal to my height. So I would go ahead and do this check and then come back and check your answer. But I'm going to go ahead and continue it. So stop the video, check your answer, get the most out of this. But the geometric mean is 12. So remember that my geometric mean falls here between the values of x and 9. So therefore, I know that 9x is equal to 144 when I cross multiply. Divide both sides by 9, and x should be equal to, so x is equal to 16. So we have 16. Now we have another right triangle right here, this right triangle, and this is A, B, C. So you can use your Pythagorean theorem for that. So again, A squared plus B squared is equal to C squared. So 16 squared plus 12 squared is equal to C squared. So C is, in this case, Y is equal to 20. We were able to find that side is equal to 20. We were able to find X was equal to 16. And so now you can solve for Z using the Pythagorean theorem again. You know, you get A, B, C. So you would have 9 squared plus 12 squared is equal to Z squared. This is what, 81 plus 144 is equal to Z squared. Z squared then is equal to 225. Find the square root of both sides, and Z is equal to 15. So there you go, using Pythagorean theorem and just knowing that one geometric mean for the altitude of a triangle, altitude of a right triangle, and it answers all of that stuff. Just do some cross product property and go with it. And then here, I guess, looking at this, Diego wants to find the height of a half pipe ramp at a skate park near his house. To find this height, Diego holds a book up to his eyes so that the top of the book of the ramp, the top and bottom of the ramp are in line with the bottom edge of the binding of the book. If Diego's eye level is 5.5 feet above the ground and he stands 6 feet from the ramp, how tall is the ramp to the nearest tenth? So just look at this as a right triangle. There is my right triangle. Here is my altitude. So 6 is going to be the actual geometric mean. So setting that up, again, 6 is equal to something over 6. So 5.5 over 6 is equal to 6 over x. And then you cross multiply. 5.5x is equal to 36. Divide both sides by 5.5. And then x is equal to approximately 6.55 feet. So you have 6.55 feet. And then it says you can use that geometry. We just calculated all that. The height of the ramp is the total length of the hypotenuse, which is 6.55 plus 5.5, because that is how tall he stands. And which is approximately going to be 12 feet. And that's coming up with that answer. Just, you just had to look at that and say, hey, my right triangle is right, it stands on, I had to reorient it and think about what I was doing. So there you go. That is being able to utilize the geometric mean, understanding that, take away the height, the altitude of a right triangle is the geometric mean of the two pieces that it splits up. And then from there, you can work with the Pythagorean theorem, and the rest of it is all similarity. So there you go. And that is working with the geometric mean.